Good afternoon, and thank Rusty, thank Teresa. Before I start my presentation, I come from India, and we have constructed IIT Hyderabad, and I am working in Larsen & Toubro construction company, which is the Indian multinational company and has its presence in 50 countries worldwide. We are having interest in construction, infrastructure, power, energy, hydrocarbons, shipbuilding, defense, finance, and information technology, apart from others. So let us move for our presentation. This is flow presentation. A snapshot of IIT Hyderabad BTBME building, design brief about BTBME building, challenge and face during construction, and rendered views versus completed view. Rewards and recognition. So IIT Hyderabad is one of the premier institutions of India, and it is built on 640 acres of land. The campus consists of academic blocks having all branches of engineering, then international guest house, knowledge center, convention center, incubation park, research park, sports and culture center, apart from others. And beauty of this campus is whatever we have constructed is all building is having exposed concrete finishes, which doesn't require any painting or plaster. You can have a glance of this. Very good. That is the building had with DNA shape. This is IIT campus in which this BTBME building is located. This honor is Indian Institute of Technology, and we, Larsen & Toubro, is the main contractor, concrete supplier. Arcop Associates is the architectural firm based out at Delhi. Tata Consulting Engineers is PMC based out at Mumbai. Technical Project Consultants, they are a structural consultant based out at Noida. This project duration was 18 months, and floors are G+4. This is BTBME building. Actually, this building is having design concept of GRIHA, that is Green Rating for Integrated Habitat Assessment, and comply to energy and efficiency, safety and security compliance, barrier-free design. Basically, is compliant to green technology and having several parameters like bioclimatic design, wall optimization, roof optimization, fenestration optimization, daylight optimization, artificial lighting, daylight, and all becomes adds to building energy performance. And then this is barrier-free designs, easily accessible for equitable people as well as physically challenged people as well. Now come to the basic concept of BTBME building. This BTBME stands for biotechnology and biomedical. Biotechnology is the use of an organism or a component of an organism or other biological system to make a product or process. Many forms of modern technology rely on DNA technology. And biomedical engineering includes bioinformatics, making devices to collect, analyze, and interpret biological data such as DNA analysis. So the building concept and shape is inspired by DNA module. A DNA molecule is made up of two linked strands that wind around each other to resemble a twisted ladder in a helix type shape. Each strand has a backbone made of alternating sugar and phosphate groups of double helix shape of DNA, symbolizes the interconnection between faculty and students. This is the evolution of BTBME building, how we started DNA molecule, and this is the steps, final steps taking place. This is the final evolution. So biomedical having two wings, biotechnology having two wings. This topography survey was made to minimize the surface treatment and optimize the available levels there. The site plant concept area, main focus was to have create more greener zone. And again open air auditorium is there. This is a movement pattern of patterns for students and faculty. You can see from hostels, this is a movement pattern from this faculty housing and from service routes. This is movement pattern for bicyclists to reach to the building. Landscaping plan is just extensively designed, and we have got pathways to have this green as a visual suitor for this inhabitants. This is the 3D model of the building. This is foundation details, the column details. This is staircases. Now coming to architectural plan, this is ground floor plan. You can see the green space between two wings to just create a relaxing atmosphere for students. This fire exits and travel distances. This first floor plan. So you can see that this head of department chambers and again faculty chambers are designed in the center to have easy access to classrooms and at labs, laboratories. Second floor plan, you can see that we have got one this amphitheater. Terrace is a reasonable amphitheater, open air amphitheater, and both the wings are connected by breeze. This third floor plan. So each lab and module is having one shaft to take extensive services. This is fourth floor plan. So all these electromechanical equipments are located at the fourth floor, which is concealed by parapet walls. This longitudinal section is 22.3 meter height building. This is cross section. This building elevation is designed with combination of precast panels, concealing the electromechanical services and double glass unit with part of noble panel. Data sheet, we are having 4G+4. Total built up is 90,000 square feet. The structure beam frame system, and is aerated cement concrete blocks we are used for masonry. Flooring is predominantly VT5 and granite. Classrooms are hardonite flooring. This internal finishes, wall is having plaster and paint surface, and ceiling is having semi-plaster, paint and mineral fiber false ceiling. External finishes exposed architectural concrete finish with grooves. Fenestration is double glass unit, and all electromechanical equipments are having design build on design basis reports, and having a special access for these physically challenged persons. This further information. Both wings, biotechnical is having classrooms, dry labs, wet labs, research labs, as well this biomedical having the same facilities. Now we can come to the difficult this portion of this building. There are two complexities there. One is technical, other is external. So technical complexity was there. Complexity in construction 2D curved walls. The all walls are curved, having 70-degree inclinations. Next is thin walls are so slender it is hardly 150 to 180 mm thick. And then every exposed wall is having a form finish with grooves. We are having a spiral staircases located both sides, that is 3D spiral staircases, and having considered precast panels, which is concealing all electromechanical services. So you can see, elaborate further. You can see the doing constructions. This RCC part wall with grooves and curves. This shear wall, right side. You can see the cylinder, this fin walls, 180 mm thick. This RCC part wall with grooves and curves. And this was the most challenging, the spiral staircase, the 3D spiral staircase. So this is during construction, this is complete view. And we can see that precast panels, which is concealing all MEP services. This is both having front elevation as well as rear elevation. Apart from the technical challenges, we have faced external challenges in the form of COVID-19. We faced this onset of COVID in 2 times, in 6 months in 2020, another 4 months in 2021. And you can see that we have kept isolation ward, we have thermometry system for staffs, and see the left hand side, around 3,000 laborers, we have to send them off because they are hesitated to stay in the campus during COVID time. And again, you have to remobilize them, so it was not easy task to again get back to the schedule. So it hampered, like productivity was all time low, and we have to go for staggered work shifts, maintain social distancing, this disruption of supply chain. So all challenges we have overcome, and finally we just constructed the building. So journey of these iconic structures, I can show you. This is excavation stage, this is mud concrete, this is a grade slab, this is first floor slab, 3 floor slabs, this is the top view, this is elevation, this is inauguration of the building, and this is what you get here, this completed view of this BTBME building. So now just we go to this another comparison, what is rendered view and what is completed view. So this was the rendered view of the building, and this what is completed view. Left hand side is material science building, and see that this is right side is chemistry engineering building, and the right side is biotechnical and biomedical engineering building. This is a rendered view of elevation. This is completed view of elevation. This is side elevation, rendered view. This is what we got. This is spiral staircase rendered view. This is completed view of a spiral staircase. And this is the top view of terrace. So how we maintain the quality here? We sourced fly ash and cement from the single source to have uniform concrete set. Next was we have an on-site concrete batching plant to maintain better quality control. And we have installed dedicated reinforcement steel plant and automated decoiling, shearing and bending equipment to address the requirement of curvilinear structures. Plywood uses were restricted to only 3 repetitions to have better finishes, and thorough checking, precise detailing have been made to ensure grooves are perfectly in line with architecture requirements. We adopted beam model to have better insight on interface issues. The rewards and recognition, we got 5-star rating from British Cities Council and Sword of Honor. We got RISPA Gold Award also for this project. From Indian Concrete Institute, we got this Best Outstanding Structure Award. And this is a appreciation from a client for the best quality form. Thank you.